Welcome to this 5th tutorial in OpenCV. In this tutorial, we're going to Google OpenCV, and then we're going to go to tutorials. And then we're going to go to the core functionality, core modules, basic building blocks of the library. Then we're going to go to adding blending to images using OpenCV. We're going to scroll down, and we're going to click on source code Python. And we're going to go all the way down. We're going to download the Linux logo.jpg and the Windows logo.jpg. We're going to click on the Linux logo, right click, save image as, save it to our desktop, and hit the back button. And the Windows logo, click on it, right click, save image as, save it to our desktop. And we're going to hit the back button. Now we're going to hit Control Home to go to the top. In the tutorial 4, we went over the theory. In this lesson, we're going to click on Source Code Python, where it says download the source code from here. We're going to click on here. And we're going to hit Control A and copy. Control A to select all, and then Control C to copy. Now we're going to go into PyCharm. So we're going to hit Control V to paste. We're going to drag from our desktop, drag and drop the Linux logo into our Python project, and then the Windows logo into our Python project. And as you can see, we have the Linux logo and the Windows logo. Now we're going to hit the Run button. And we're going to enter alpha of 0.5 and hit enter. As you can see, the Linux and Windows logos were blended. So now we're going to go back to the tutorial. So we're going to go to the tutorial, and then we're going to hit the back button. Now we're going to hit Control Home to scroll up to the top. And we're going to hit back button again. Now we're going to go to changing the contrast and brightness of an image tutorial. You can click on that. Changing the contrast and brightness of an image. Goal in this tutorial, you learn how to access pixel values, initialize a matrix with zeros, learn what saturate cast does and why it is useful, get some cool information about pixel transformations, improve the brightness of an image on a practical example. The explanation below belongs to the book Computer Vision Algorithms and Applications by Richard S. Image processing. A general image processing operation is a function that takes one or more input images and produces an output image. Image transformations can be seen as point operation, pixel transformations, neighborhood, area-based operations. So either pixel transformations or area-based operations. In this pixel transformations, in this kind of image processing transform, each output pixel's value depends on only the corresponding input pixel value plus potentially some globally collected information or parameters. Examples of such operators include brightness and contrast adjustments, as well as color correction and transformations. Brightness and contrast adjustments, two commonly used processes are multiplication and addition with a constant. G of x equals alpha times f of x plus beta. The parameters alpha and greater than 0 and beta are often called gain and bias parameters. Sometimes these parameters are said to control contrast and brightness respectively. You can think of f of x as the source image pixels and g of x as the output pixels. More conveniently, we write the expression as g of I, comma j equals alpha of f I, comma of f of I, comma j plus beta, where I and j indicates that the pixel is located in the ith row and jth column of our image. We're going to click on the Python code. The downloadable code is at the link where it says click here, where everything is formatted correctly for use in Python. That's the only way we want to do it, is use the link, because down here when you cut and paste, some reason the indentation is not correct. The indentation is only correct in the link. The following code performs the operation g of I of j equals alpha times f of I of j plus beta. We go down, explanation. We load an image using CV imRead and save it in a matter matrix object. Now, since we make some transformations to this image, we need a new matrix object to store it. Also, we want to have the following features: initial pixel values equal to 0, same size and type as the original image. New image equals np.zeros image.shape image.dtype or data type. We observed that CV mat zeros returns a MATLAB style zero initializer based on the image size and image type. We now ask the values of alpha and beta be entered by the user. Alpha is the contrast control and beta is the brightness control. Now to perform the operation g of I of j equals alpha times f of I of j plus beta, we will access each pixel in the image. Since we're operating in BGR, blue, green, red images, we'll have 3 values per pixel, blue, green, and red, and we'll access them separately. As in the code below, Y is for blue, X is for green, and C is for red. Where the new image X, Y, C, those are blue, green, and red. So since the operation alpha times P of I of j plus beta can give us values out of range or non-integers if alpha is float, we use CV saturate cast to make sure that values are valid. Finally, we create windows and show the image in the usual way. CV.imShow shows the original image. And CV.imShow new image shows the new image. And then we wait until the user presses a key using CV.wait key. Instead of using for loops to access each pixel, we could have simply used the command below. CV mat convert to would do the same as above. Here's an example using our running our code and using alpha equals 2.2 and beta equals 50. You can see Lena before and Lena after. And there's another type of correction called a gamma correction, which is below, but we're not going to do that. We're skipping the gamma correction. But in the alpha, where we used alpha and beta, you can see where alpha was 1.3 and beta is equal to 40, the before and after photo. Then they have a gamma correction, which we're not doing, and the code on the gamma correction. So we're going to hit Control Home. In the next tutorial, we'll do the changing the contrast and brightness of an image using our alpha and beta values. And this operation, g of I of j equals alpha times f of I of j plus beta. See you next time. If you liked what you see, please give a thumbs up. Thank you for watching. Add comments or questions to help the videos be more useful to you. See you later.